Sonia Bailey, and today I would like to share with you the most scientific way to cut a cake. So some of you might be wondering, well, why would we talk about cake? So just to tell you a little bit, I love to bake cakes and I love to decorate them. I do them for my kids' birthdays and weddings and anniversaries, you name it. So I saw this video online and it talked about the most scientific way to cut a cake. And so I thought, well, what about the numbers behind it? So I decided to come up with my own little experiment. So I'm going to show you how they say to cut a cake. So probably all of you, when you go to cut a cake, you're going to take out like this triangular piece. So now we're going to pretend that you get to eat the cake all by yourself. So nobody else gets to eat it. So if you were to cut out that triangular piece and then put it, say, in the fridge overnight, and then when you take it out the next day, those two sides where you cut from are now hard. So you may cut those off and throw them out. So now you've wasted the cake that you get to eat all by yourself, or you just deal with the hard cake. So instead of doing it like that, I'm going to show you a better way to cut the cake. So what we're going to do is find exactly where the center is. I know, and this is like really against all normal cuts. And I'm going to take out 1 inch directly from the middle. So this is the cake that you get to eat. That's a lot. And then what we're going to do is we're going to take the cake and we're going to squish it together. So we're just going to assume that we put it in the refrigerator overnight. So if you were going to do that, what you could do is actually put a piece of rubber band around it so that the place where you cut is now going to stay fresh. Okay, so we're going to kind of pretend like we put it in the fridge. We come back the next day. Now we're going to turn the cake 90 degrees, and I'm going to make the same kind of cut. So I'm going to go ahead and find where the center is, and I'm going to cut a 1 inch slice right down the middle. And now what we're going to do is we're going to squish the cake together, and again, assuming that we're going to wait till the next day, we're going to go ahead and put that rubber band around it. We'll come back the next day. We're going to turn it 90 degrees. Now the thing that's kind of interesting is I already have one cut here, but I still want to cut out 1 inch. So I'm going to have to actually make 2 kind of cuts around that one piece. So assuming my measurements are very precise, we have exactly 1 inch. And so we're going to have to kind of cut out these 4 pieces. And then what we'll do is we'll just kind of squish the cake back together, and then that pattern would continue. So now here comes the math. So I went and did this diagram. So we're going to assume that the circle had a radius of 6 units. So I went ahead and decided to look at the volume for that circular prism. So using V equals pi r squared h, the volume for the original circular cake was 108 pi inches cubed. So then we went ahead and made that 1 inch cut. And now this is where the fascinating math comes in. So when you go ahead and squish that cake together, now you have an elliptical prism. And that's really, really cool to me. So then I went ahead and I found the volume for that. Okay, so using V equals pi ABH, our minor axis is 5.5 units, but then our major axis is still what it was before in terms of the radius of the circle at 6 units. So now we're at 99 pi inches cubed, and then here is that one sliver that was kind of taken out from the middle of the cake. So then we went ahead and we kind of squished that cake back together, and now what we get is a circular prism. So we're getting this pattern of a circle to an ellipse and back to a circle. So I went ahead and I calculated the volume, again, using the volume formula for a circular prism, and I got 90.75 pi inches cubed. So what we're noticing is that we have a pattern. So when I then kind of squish that cake back together again, Now what we have is another elliptical prism. So I went ahead, I figured out the volume, and it's now 82.5 pi inches cubed. Okay, so we've got that right here. So now our major axis is the 5.5 units, our minor axis is the 5 units. So kind of not doing all of the actual cuts. The next one though, as we would notice, is that it's a circular prism. Okay, so the next one is the circular prism, and the volume is now 75 pi inches cubed. So I thought that that was really fascinating. We go from circular to elliptical back and forth until eventually we wouldn't be able to cut the cake anymore. So what I did is I ran some numbers. So I went ahead and looked at how long would we be able to actually make those cuts, assuming that the cake doesn't crumble. So I have this sequence in terms of the volume, and the last one would be 0.75 pi inches cubed. So I saw this sequence and thought, okay, what does that really look like? So I went to my TI Nspire and I plotted those points, and it looked like a quadratic function. But obviously it wouldn't be both sides, just the side of the quadratic that was decreasing because the volume was decreasing after each cut. So I ran the regression and got the equation and found the r squared value such that x was the cut number and then y was the volume. Okay, so those were the things that I ran. I found that to be really fascinating, and I hope that you do as well. But I wanted to leave you with a couple of questions. So what if we considered instead the circumference? And what would happen? What if instead we considered the surface area? Now this is kind of interesting to me. What if we cut the cake exactly the same way, but you had to keep the volume the same each time? Okay, that would be tricky. Okay? Or what if we looked at the residuals when we went to our calculator? Okay, what if we changed the shape of the cake? What if it was somehow a square, or we looked at a triangular cake, or even like a pentagon? Like what would happen? What is the domain and the range? And then kind of realistically, when do you think the cake would actually crumble? Okay, so those are just some things to think about and leave you with. So hopefully now you're all going to go home, you're going to make a cake or a pie, and you're going to try this yourself. Thank you very much.
Nice job.
You want suggestions?
Yes, please.
I think when you, after you cut, you should kind of lift so that people can see the top. Do you know what I mean? Lift
Okay.
it like just to,
Okay,
so they can, unless
that's
they
a good
have.
idea. Yeah, it'll kind of, I mean, it'll
Like
stay.
that, perfect.
Yeah.
Yeah. So that they get.
Make
See
the
the
cake,
ellipse,
the cup
yeah. Because I
a little
didn't
bit.
think about the ellipse until you showed it up
Until I
there.
showed it here.
If you show
And
it
I
closer.
could talk about it here. I just kind of waited
Mm-hmm.
till there, but I could talk about
In real
like,
life.
I could even
you-
like ask like what does the shape look like,
Correct,
and then
correct.
say something like then talk
You
about
could
it
even
there.
wait a little minute to see, look at.
Like squish
Yeah.
it together and say, okay, now look at
And-
the shape.
I think you should point out that if you make the inch slice every time, you're changing volume.
Okay.
I mean, I like your point, like if a person were gonna eat it alone, I know it's too mathematical, but if a person, they'd want the same amount of volume on every cut. Now that gets very tricky, so you take the volume of the cake,
Mm-hmm.
and then what would my cuts have to be?
Have to
Because
be,
I was
right.
trying to see the pattern of the volumes, it's
Mhm.
9-ish, but then it
Right. It
changes.
decreases.
Yeah,
Yep.
type of.
Is that's what you said at the end? Is if you want the volume to stay the same every time, the volume
Correct.
of the slice?
Correct.
Right.
Yeah,
right.
that's an
In other
interesting.
words, the amount
So-
the
Back to your
person,
question.
the amount the
Well, I
person.
put it in there, but I could reiterate it. Like,
No, I think you need to
and what
add,
you want, because I said like, what if the
Reread the-
cake, like, what if we cut the cake the same way, but each consecutive cut had to be the same volume?
yeah, I think that needs to be clarified.
And like
Okay.
ask
It
it
didn't
more,
sound
right.
it didn't
Yeah.
sound like
Okay.
that.
It
I
didn't.
So-
think you could just preface it as you want the same slice, the
You
same
make
amount of
the
cake
same
every
thing
slice.
every
How
day.
can we make
Yeah.
that happen?
Right.
Yeah.
How
Versus
can we
this
make the
making cuts
volume?
the same
Yeah.
way. So first thing, make sure that when you do all of those, outline all of the circles, like, cause back here, it's
Can't
very,
see.
it's not easy to see at all. Like,
Okay.
it's just because it's white on white.
Well, it also makes it difficult because you see the measurements, but it's so close to being a circle, it's almost impossible to recognize it as an ellipse. I mean, you're saying
Right.
it, but.
But you
Right.
can, and make sure, because it looks like you went out of your way to keep showing that. Almost if you wanted to keep track of the cut volume out to like extend that, because each one is the 1 unit cut. But you may
Right.
even want to, not saying it, be like, all of these have the same volume. It's just that
Well,
this
they
one.
don't all
They
have
don't.
the
No, no,
same
no,
volume.
you're not. If she put the
Yes,
amount of
yeah.
volume that she was taking out each time,
Oh.
each one consecutively
right.
would contain the same volume. When you
It would
go,
be hard to calculate that volume though, wouldn't
It
it?
is.
Oh, just
It'd
the
be-
original minus what you took,
Yeah.
what year left.
have her slices
She's got
be
the
on the
little
side.
slices on the right hand.
Your
So-
cut would be very,
Yeah, but you
difficult.
could, there's no formula to calculate that because there's a curved top and a curved bottom.
correct.
Right, which is my feedback, which is really nitpicky.
Yeah, another
Your
really
one
nitpicky.
unit cuts are all rectangles.
Yeah.
I don't know
Oh.
if you can do
Well,
anything to make
they're-
them a little rounded on the head,
They
or are they?
kind of are a little rounded.
Oh,
like you
okay.
can't,
But it's so small,
hard
it's
to
almost
tap.
impossible
It's
to
so,
see.
yeah, right, so they are, so, because what I literally did is I made 2 of these circles, and then I
And you
cut
cut
one
one
of
out.
them, and then that's the piece right there.
Okay,
like,
so
there
that
are,
is
like-
actually rounded on the edge.
Right,
Okay.
like it's a little, I mean, it doesn't look like
Did
much.
you tape it back together and then cut again?
Mhm.
That's cool. That's really
Yeah,
cool.
good thing I have that island. My house. Yep,
Mark was gonna say.
Well, I just super nitpicky is just say that can be, that's not an elliptical. It's not an ellipse, it's an approximation of an ellipse. Just say that,
Okay.
right? This can be
Right.
approximated by an ellipse,
Okay,
just to
yeah,
sound
'cause
more
it's not-
mathematically.
right, because it's not perfect.
Right.
Otherwise, if it was perfect too, then this would have come out, you know, different,
Mhm.
so.
Well,
Okay.
that's a good point, though. I mean, you're
Yeah, well,
modeling the
you're
real
modeling
world.
the real world. This is
Right.
approximately an ellipse. This is a good way to
Right,
model
Right,
it.
Right.
okay, no, that's good.
Well done, my dear.
That was good. I
think it's
liked it.
cute.
That's very cute. You're gonna hand out cake at the end?
Yeah.
Right, so then I think like when I'm done, I can say now, you know, if it's okay, you know, we can all consume some cake, like.
Or after the last person
or
goes?
when
Yeah.
everybody's
Yeah,
done,
definitely.
yeah. then.
Cool.
But I am gonna make sure I go first, like you said.
How many people are there?
It'll be about 4
There should-
presenters.
Yeah, it'd be like 4 presenters, like in one room at a time.
How
Okay.
was the time?
She was
at 7:45.
That's good, that's
And
good.
you have to be.
But if I
between what and
explain
what?
more, a
10
little
minute
bit, even
limit.
just a couple of things that everybody said, I'd be at
Mm-hmm.
over 8. Or if I was more careful, like with my cuts and like even tug out that, or like you said, show it,
Yeah.
like it might take a little bit longer.
I think you really need to slow down a lot more than you did. Like, you could easily go to 11 minutes. Like,
Okay.
even when you were talking, when you watch it back, you'll see it. In the beginning especially, and I'm assuming this probably makes, like, less than 5 times you probably run through the whole thing. Like, the slower you go, the
Right.
better. There's no such thing even as too slow. When you start off in the beginning, make sure that you frame it into something, because, like, you're stating something that's just a property of mathematics. Like, it has no, it's not pertinent to who's
Are you
listening
still
to it.
recording?
Yeah.
Oh,
So you
It's,
can have all the feedback, it's hard
That's
to remember
good.
it later.
it's not pertinent to a person. You wouldn't explain this to someone and they would lose interest. Like, a non-math person would lose interest very, very quickly.
You think
Because,
so?
absolutely. Because what you're explaining, because you didn't frame it right in the beginning. So say in the beginning, so how many of you have had a cake that's like left in the fridge, right? You go out and you take that slice, and what's the problem with it?
right.
The sides are dry, and
Yeah.
that's the worst, and that's why you need a glass of milk. So here's a way to solve that. Give it as a solution to a problem as opposed to this is math. Because
Okay.
then you go and be like, it's not the most feasible perhaps, but it's a problem that we came across, and this is sort of an alternate way of answering that maybe you haven't thought of before, and some cool math relationships get shown while you're doing this progression.
Yes.
When you're, and frame it so that it's pertinent to them. And another thing to go through and do, it's going to get messy. Make a joke of it and say something like, we didn't say this would be pretty when we were cutting it up, because the cake ends up, like you're saying, especially after that 1 inch cut on each side, that's when you would say something like that to frame it and be like, in theory, this is a lot easier to do than with an actual, cake.
Or
Make-
say by that fourth time, you actually have to invite people over because there's now 4 pieces.
Yeah,
instead
make
of
it-
just-
Make light of the fact that it's not going to be pretty, but make sure that you're showing it to people as well. You may even want to put some sort of patterning and decoration on the top of the cake
Where
that
you
lets
can cut
people
it.
see like what's what and how much of the picture. Even if you did a picture on it, be like, so you see the picture is condensing each
Right.
time, and especially if you have a cake that you can almost flatten the top. Like that would probably make it stronger because you are going to have that pure
Right,
math
so I'm
person's
gonna
going.
do a two-tier.
That's not fine.
So it'll be cut
and if you
flat
do
on the
that, put like trace the outside of it so people can more clearly see. Because especially if it's white on white, you're not going to see that relationship that's happening, whether it's approximating an ellipse or going back to being circular. The other thing is on that end one, if you're trying to sort of show that out, do it vertically, like as so you're seeing it as a table instead of a sequencing of it. You know what I'm saying? Those numbers on the side to show that, like after 1 cut, after
Right.
2, and after 3. And the other thing that you can
Would you show the change even in between the two?
sure
So
if
can
you
see
want
that it
to,
actually
yeah, to
is
show like give just the decimal
obviously not
approximation.
linear, it's definitely got to be right.
I'm looking to try to find that what that model is.
Yeah.
So this would be a
So,
way to go
slice
about
1,
showing it.
slice 2, slice 3, and then the volumes along the side,
And
then
do
the
it as an
change.
exact or a decimal, it doesn't matter. Even to
Right.
have both and be like, this is what's happening each time going through. In all honesty, you could make a table with cut, exact volume, approximate volume, and then change. And that would show it to them clearly as
That's
to
a
what's
good
happening.
idea. Scatter
And-
plot?
Alternatively.
You think it's scatter plot?
You could do whatever you wanted, but I'm saying give the table.
Alternatively,
I'd like to see a
if you
scatter
left
plot
You
this,
could.
dots.
if you
I mean, that would
left
be
them
sweet.
there,
That would
and
be
you
cool.
mentioned, I use my Inspire, why not